I'm Jerry Herbst, and we're getting down to the brass tacks and hard facts of the 4 basic types of handline nozzles. The simplest of the 4 designs is the smoothbore nozzle. It's simply a ball shutoff with a smoothbore tip. The smoothbore tip size will dictate the flow. It's commonly accepted that smoothbore tip pressure is 50 psi. One of the advantages of being at 50 psi is being able to deliver a large volume of water at a low tip pressure, which equates to lower nozzle reaction. Another advantage of the smoothbore nozzle is the solid, compact nature of the stream. It's volume driven as opposed to pressure driven in a combination nozzle. So we can deliver a solid column of water, maximizing the impact of the stream at the attack point. Moving up in complexity, we're now into a combination nozzle. Combination nozzle commonly refers to a nozzle that has a bumper that can do straight stream or fog. There's 3 primary types of combination nozzles used, yet there's extreme differences between the 3. Here we'll talk about a fixed orifice or a constant GPM nozzle. It can be a full nozzle, it can be a 2-piece or a break-apart design. How it operates is there's a flow stem in the waterway. The flow stem is designed to come out at a certain pressure and deliver a certain amount of flow. It's end-user selectable. Like any nozzle, it can be overpumped or underpumped, but it will have a ramification if it's done by accident as opposed to intentionally. How it works: water comes through the shutoff, travels through the fixed orifice waterway, engages the stem and creates a pressure interface. At that pressure interface, I can be in straight stream or I can open my pattern to a fog. The advantages of the fixed GPM nozzle are the fact that the waterway, other than the stem, is pristine, maximizing effective stream. The next nozzle design we'll talk about is the selectable combination nozzle. These can operate at either 75 or 100 psi. Like other combination nozzles, we have the ability to do straight stream or fog. The other feature of this nozzle is I can select a GPM rating anywhere from 30 to 200 GPM. The disadvantage of this is every selection within that flow range would require a change in pump discharge pressure to be at efficiency. This design of nozzle is fairly simple. Water comes through the shutoff, travels through the waterway, interfaces with the stem and creates a pressure interface. As we dial into either a larger or a smaller flow situation, the barrel changes in relation to the stem, either letting out more water or restricting the flow. This style of nozzle is ideal for a front bumper line where we might be in a low flow situation for a grass and brush or a trash fire or something of that nature, but also have the ability to dial up to a higher flow if needed. The 4th type of nozzle we'll review is the automatic nozzle. Again, it's a combination nozzle. With a bumper we can do straight stream or fog. All automatics have a spring mechanism within the nozzle. The primary design feature of the spring is to maintain a pressure interface at the stem, which drives the effectiveness of the stream reach regardless of flow. The downside of this design is automatics have a flow range. This particular model is 60 through 200 GPM. So the false sense of security that can be gained is I can have a visually good stream at an extremely low flow. That's a review of the 4 basic types of handline nozzles. It's imperative that you have an understanding of the advantages and disadvantages of each model and how it will impact your operation.